Hello, in this video I'm going to show you a different production function, and this one is a little bit slightly different from the one we did, the other two we did in class. Here I've already drawn everything, so I just need to discuss it, so it'll be pretty fast. So I have labor on this axis, total production on this axis, and the production function here is actually linear up to L1 units. In other words, increases at a constant rate. The slope gives you the marginal productivity of labor, which is equal to the average productivity of labor, which is equal, I don't know, let's say to 10 units, 10 widgets. So no matter if we have one worker or the second worker or the third worker, each additional worker produces 10 units of output up to L1 units. Okay, and therefore the average productivity and marginal productivity is 10. If we had, okay, let's say if we had one worker, he would be producing 10 extra units of output. If we had two workers, they would be together, they would be producing 20 units of extra output. And if we had three workers together, all three would be producing 30 units of output. So on average, each worker produces 10, and the additional output produced from an extra unit of labor is 10, right? So you have basically marginal product and average product up to L1 units equal to each other and equal to 10, right? So, but after L1 units, we're having a diminishing marginal and average returns enters. So you have a production function similar to the one we did in section O3 of the class, and then it actually have it here even declining. And I said basically, well, what happens if Peter comes in as a worker and tells the previous worker, hey, let's not work too hard, let's go for a beer, and not produce. Well, his production will go down actually after this level. Okay, so the marginal product is the slope of the total product curve, and you can see it declining as you increase labor. Okay, so marginal product declines, and it reaches a zero marginal productivity, exactly where the slope is zero, right? It's flat. The marginal product is flat, yeah, and that's at L. Let's call it L2, L2, and after that, it becomes marginal product becomes negative, or total product declines, where Peter comes in and disrupts production and makes the workers less productive, etc. So he has a negative influence on it. So no firm will operate here. It doesn't make sense for them to operate here when they can go here and produce the same amount of output with less labor. Why would they pay more labor to have more workers when they can produce the same level of output here and have less workers, right? Okay. Average productivity is the slope from the a slope of a line from a line from the origin, and wherever it hits the total product curve would be the average productivity of labor at that particular point. So at L2, average productivity is positive, even though marginal productivity is very close to zero. So it would be somewhere up here. Okay. Also, average productivity, you can see it after L1 units, also declines as you increase labor. Okay, so average productivity declines. The other thing to note is that because the marginal productivity of labor is less than average productivity of labor, average productivity of labor declines. Yeah, and you can see that you can see that average productivity is above marginal productivity. If you look at that particular point here, where the slope is marginal productivity is zero, average productivity is still positive. Yeah, at this point here. Yeah, that's it. I think that was a short one. Up you go, up you go. There we go. Good job. Okay, bye now. Lots of things to think about.